So welcome to today's seminar, which is part of the summer seminar series of iWest. Next slide, please. Before introducing the speaker of today, Dr. Stephanie Arcusa, I would like to remind you of the iWest initiative. So iWest is a collaborative initiative with partners across the Intermountain West, and you can see some of the main partners shown on this slide here towards the right. At the moment, we are leading this effort with Scott Killian of University of Wyoming, School of Energy Resources, and Los Alamos National Lab, myself towards the left. And we're currently working on working with our sponsors on the next phase of the iWest initiative. Next slide, please. So just a friendly reminder, the iWest initiative provides the Intermountain West region, or Intermountain West states, and sovereign nations with data, tools, and information for energy transition and planning. And some of the keywords in this initiative are a place-based approach, a technology-neutral approach, and an integrated approach. So it's very important for this initiative to integrate assessing technology readiness in tandem with societal readiness for a just and equitable energy transition. And we do this through a community-engaged research and coalition building to encourage regional partnerships. Next slide, please. So today's seminar speaker is Dr. Stephanie Arcusa, and she is from Arizona State University. And Dr. Arcusa today will talk about a very important component of energy transition, and that is carbon sequestration certification. And I'd like to remind you that she also authored a fantastic chapter in the iWest report. So I'd like to invite you to read that chapter. The chapter is about carbon sequestration certification. And today she will address a couple of components of this whole process. Dr. Stephanie Arcusa, she received a bachelor's in earth science from University College Cork in Ireland, and then moved on to Switzerland, University of Bern, where she received a master's degree in climate science. After that, she moved to Arizona and received a PhD in climate and environmental change from University of Northern Arizona. Then she moved to Arizona State University, where she's currently working as a postdoctoral researcher in the ASU Center for Negative Carbon Emissions. Stephanie, please go ahead.
Thank you very much for this introduction, and I'm very pleased to be here today. If you wouldn't mind going to the next slide. Great, thank you. So today I thought I would give an overview on the why, the what, and the how of carbon sequestration certification. Next slide. The reason being is that right now, carbon sequestration is underpinning global climate change mitigation efforts. And what I want to show you is how only through robust certification programs will we know we are successful in these efforts. Next slide. And if we start from the top, we are in a situation where most of the world is now experiencing impacts of climate change. And these impacts are showing up in different ways in different regions, but the scientific community is basically warning us that these impacts will continue to increase in severity. Next slide. We also know what is causing these changes. The main driver of climate change is the unmitigated waste stream of CO2 that is resulting from the still rising consumption of fossil fuels. And by unmitigated here, I mostly mean unabated activities. Next slide. We also know from the scientific community that once CO2 is in the atmosphere, it basically will stay there forever on human timescales. This is a graph that is showing the concentration of CO2 in the atmosphere over very long timescales. As you can see on the horizontal axis, the lines are showing you the concentration of CO2. In the black, it is what we have measured in ice cores. And in the red, orange, and blue, it is what we are modeling is going to be the impact of our future activities. Of course, we don't know what the future holds, so we need several different models to kind of assess what is the range. But what you can see is that no matter how much we put into the atmosphere, the return of the atmospheric concentration to what was considered normal, which is in the black, will take hundreds of thousands of years.
Okay, you might show me.
Next slide. And so what happens is because of this very long time scale of CO2 in the atmosphere, every single ton of CO2 that is added to the atmosphere accumulates and adds to global warming. Next slide. Now, we know climate change is a problem. We know what's causing it. The next part is understanding that it's actually a solvable problem. Next slide. The solution is that we must avoid emitting and we must remove everything that we do emit. Removing is the price to pay for not avoiding in the first place. Next slide. So what this means is that we actually need to reach a global emission level that is near zero. So this is through very dramatic emission reduction. But what we will find is that even with our best attempts, there are some sectors that are incredibly difficult to abate. And this may be long-range transport, steel, and high-reliance electricity. And these would account for 30 or 20% of global emissions. And even for the emissions that are technologically easy, we may find that they are socially and politically difficult. Next slide. So in the interim, the idea is that we will be going towards net zero as our goal. And what net zero means is that we are balancing any emissions with sequestration. Most of the world emissions, about 88%, are now covered by a net zero pledge. So we are moving in a direction of climate action, but collectively we have decided it is net zero that we are aiming for. Next slide. And so what this means is that we are going to need a tremendous amount of sequestration. If you look at this graph, which comes from the Intergovernmental Panel on Climate Change report in 2018, it is a stylized modeling of the future of what we would need to do in order to limit global warming to 1.5 or 2 degrees Celsius temperature increase. On the y-axis, the vertical axis, everything that's above the zero are our emissions. Everything that's below the zero is sequestration. And as you can see, from the maybe 2035 to 2050 onwards, we will need increasing amounts of sequestration. Now, this means we're going to need to develop our capacity for storage very rapidly. And here, just for comparison, 1 gigaton of CO2 is equal to 5.5 million blue whales. This is a massive, massive industry that we're talking about. Next slide. And to put this into a more regional context, the Intermountain West is also going to need tremendous amount of sequestration. This is a very nice graph provided by our seminar's last seminar speaker, Dr. Vicara, on one scenario for the Intermountain West region. So you can see in the grays are the current and past emissions, and everything that's in blue and green and yellow are one possible pathway for the future. And what is highlighted on the right with captured CO2 and from the point source or the air are going to need sequestration. So this is a tremendous need for the Intermountain West region. Next slide. So all of this points to this kind of developing sequestration industry. Next slide. So what do we mean by sequestration? there's a lot of talk about separating point source capture and sequestration from this other set of technologies called carbon dioxide removal. But in the context that I'm talking about today, it doesn't really matter where the CO2 is coming from, because whether the CO2 is captured from the smokestack of a power plant, or whether the CO2 is captured from the atmosphere or the ocean, the CO2 has to be sequestered somewhere into a reservoir. And so in this image, I'm showing you different types of sequestration. So in the middle, you have this power plant where the CO2 is captured at the smokestack and then injected in some kind of underground reservoir, which could be a depleted oil and gas reservoir or a deep aquifer or a basalt formation. But the CO2 could also be captured by direct air capture and storage and equally injected. We may also think of more conventional methods like afforestation and reforestation, or some kind of novel methods like enhanced weathering, which is the spreading of very special rocks on the Earth's surface so that they can react with atmospheric CO2, or the spreading of iron and nutrients in the oceans to fertilize algal blooms. Or you may also think about sinking biomass. So there is a whole range of sequestration methods that are possible. Next slide. And I should say that having this whole range of activities is actually a worthwhile thing to develop, because research has been showing that the more we diversify, the smaller the negative impacts, and also the lower the overall risk of failure. And that's because every method is different. It's different in terms of its durability, which simply means how long we can expect the CO2 to remain sequestered. It is different in terms of the risk that the CO2 will come out, the costs and investments to develop and deploy, the readiness of the deployment, as well as the ability to verify the sequestration, the benefits and side effects, and the justice-related topics associated with each of those methods. Next slide. So to just focus on two of those dimensions, one is durability, which is that each reservoir is going to be expected on average to keep carbon stored for various lengths of time. The easiest one to picture is if we think about a forest or soils, just by the nature of the biotic systems, we know that the CO2 will remain for shorter amounts of time than if we think about a rock, which is by its physical property much more stable. So each method of sequestration, each reservoir is going to have its own expected storage duration, which is going to vary tremendously. Next slide. And another way that they vary is through their verification readiness. And by verification, here I mean something that is broadly discussed as monitoring, reporting, and verification, MRV. And MRV is essentially kind of a system way to think about carbon accounting. And one way we can consider how ready the MRV for each sequestration method is by understanding the level of precision that we are able to reach in the measurements and the cost associated with deploying those sensors and technologies. And you can see that a lot of these technologies or sequestration methods may be more ready than others. Next slide. But to build this sequestration industry, we're going to need a lot of development in terms of research, in terms of deployment, and especially in terms of supporting infrastructure, which is really the key part that I want to get into now. And in that kind of supporting infrastructure, I am including regulation, accounting standards, and certification. Next slide. So certification, I want to present it to you as a tool that builds trust. Next slide. And so the first question to ask really is, why do we even need standards, certification, and verification? And there's, in my opinion, three really important aspects. And the first one is safety, because we're going to be moving enormous volumes of CO2 into storage. And this is going to affect everyone globally, because this is a tool for climate mitigation, but also locally, because people are going to be living close to these deployment sites. And it's also a temporal activity. It's not only going to affect us today, it's going to affect our children and grandchildren in the future. The second aspect is performance. And the reason being that we are putting this idea that sequestration is a cleanup of emissions. We are allowing the fact that we will continue to produce emissions by the promise that we're going to clean up those emissions. And that means that every single sequestration activity must hold that promise in the same way. So there's a key performance component to certification. And the third part is just because we're going to be moving this odorless, colorless gas from the atmosphere into a black box that very few people are going to have access to. And that is going to require a lot of trust from everybody that we are doing what we say we are doing. And the second part of that is successful sequestration will not be noticeable for years to decades. And that could leave a very wide margin for manipulation. And so, in a nutshell, the role of certification is to provide direct and indirect assurance that the product, the service, in this case, sequestration, is meeting certain claims. But in kind of the landscape that we're in today, that role of certification really needs clarification. Next slide, please. So certification, just a little bit more detail, is really a process. And this is kind of simplified still, but you essentially have a project or an idea for a type of sequestration that is then encoded into a standard. So how are you going to develop that particular idea? How are you going to implement it? How are you going to measure it? And so on and so forth. And through an independent verifier or auditor, you will then go through a certification process that will result in some kind of instrument that represents sequestration that is then able to be traded. But what I would like to point out is that this entire process rests upon the ability to account for stored carbon. Next slide. And so the way I've come to think about this, based on the research I've been leading at ASU, is that we really want to be certifying tons that are stored permanently, safely, and ethically. And the way we're trying to think about the process of certification is in terms of these layers of questions that we really need to be gathering evidence on in order to convince ourselves that we are actually doing what we say we are doing. And so the very core layer is, do we have the evidence and the methods to collect that evidence so that a proposed method actually does store carbon and can be actually measured? And then the second layer is, if you are able to prove this, can you actually demonstrate that it is fit for purpose? Are you actually doing a net benefit in terms of the environment, or are you, mitigating the climate but completely destroying an environment? That would not be an acceptable trade-off. And the third layer is, okay, it's a method that works, it's fit for purpose, but can it be implemented ethically and safely? And this is where the whole community engagement comes in, and making sure we have strong labor laws and so on. Next slide. But standards are really kind of the way to answer these questions, and they bring together science, business, practice, and policy. And all of these aspects will have trade-offs and they will compete in certain ways. Next slide. So from the scientific side, really what the scientific community can bring in is a better definition of what are the questions to even ask. What is the state of the system? How does the system work? How to design experiments that will find that evidence we're looking for. And of course, how to observe and measure and replicate so that we can be convinced with the answers that we are collecting. Next slide. But then there's a whole suite of decisions that will need to be made. And some of those are, can you click one more, please? Oh, okay. If you go back, sorry, something is wrong with this slide. So some of the open questions that are really policy decisions are, how do we want to treat the concept of additionality, which is the idea that we must make sure that we are not pretending to be adding sequestration. We're actually doing more than what was already the case. The questions about durability, for example, how long is long enough for sequestration to be useful? Or questions about whether carbon removal can be considered the same as emission reduction and how to make that work into the system. There's also questions about what is even a carbon offset and what are the claims that can be made, or whether we should be considering co-benefits or other greenhouse gases. So there's a whole host of policy decisions that go into a standard development that have nothing to do with science, that are value-based questions, but they're equally important in the success, I guess, of the certification system. Next slide. And then there's this entire whole other aspect of standards, which is at the end of the day, this is a business practice. And is the business implementing this responsible? Do they feel a responsibility for their actions and how they're operating in the world? Are they trying to provide a guarantee for their product or service? And do they embody ethical practices into their business model? So what I'm trying to show is that we may think of a standard as just like this piece of paper that is technical, and it will give us what we think it will give us, but within its development, there is a lot of questions and processes that make it much more difficult than one might think of. Next slide. So at the end of the day, standards in the certification process are one of the tools to foster the trust that carbon storage is successful. And what I would like to show you is that it is really critical to get it right. Next slide. And it's really critical because there are these consequences from failing to certify properly. We could be wasting immense amounts of time and resources. We could be opening the door to scams and fraud. We could be harming communities and the environment. And we could very simply fail to address climate change. So the consequences really are local and they're global and they're small and they're very massive. And the problem right now is that some of these consequences are already evident. Next slide. So what I will show you now is a bit about the current situation. Next slide. What we have, at least in the voluntary carbon market, I'm not showing you the compliance market, is that the market is currently dominated by offsets of emission reduction and avoidance, as well as emission reduction and removal that are mixed together. And those are in the red and the blue. And then about 3% of the issuance in 2022 were from impermanent removal. And if you look at the inset on the right, the little yellow bar is what we have issued that could be considered permanent removal. So we are a very far cry away from where we need to be. And that is why we really need to be scaling this sequestration industry. Next slide. And the other thing to notice is that the global market and the global certification space is rapidly evolving, and it's evolving without oversight. And what I'm showing you in this messy graph are all of the certification that are available globally, at least in 2022, and this has changed already. And all of the certifications are in the purple zone. They are being produced by at least 30 different standard developing organizations that you can see in the blue zone. And all of these organizations are creating standards for a whole suite of different types of sequestration that you can see in the green and in the yellow zones. And the standards are all of the lines. There are over 150 different standards globally. And the key to notice here is that some sequestration activities have 0 standards and some have dozens. And so we have we are in this peculiar time where it is a very unequal space. And the consequence of having no oversight is that no 2 standards, even if there are standards for the same activity, are the same. And that's because all of those decisions that I was telling you about that are being made in the policy and the business and the science, they can be combined in different ways, and they all lead to different outcomes. So the certification that comes out of these standard developing organizations has been shown to be incomparable. Next slide. And the result of that is that, unfortunately, quality is suffering. And you may have been following this in the news, but in recent months, there have been allegations that a lot of the carbon offset credits, whatever we want to call them, on the market are worthless, or they are a sham, or whatever negative word you may want to use in this space. And that's an issue. That's a very, very real issue. And you may think, yes, but this is only for emission reduction, and it's only for forest. And that's true because they've been around the longest. But next slide. But the issue is that the way the standards are being developed for carbon sequestration of other types is being developed in the same way as the standards that were used for those low quality credits. And the number one lesson, there are several lessons, but the number one lesson in our mind is that when we rely on counterfactuals to define a baseline, this gets super tricky. So a counterfactual is let's say, a statistic tool, let's say, to determine what would have happened if a project did not happen. And baselines are created from a counterfactual, and then the project, is operating and it's being measured, and the difference between the baseline and the project is how credits are being issued. And this was the only way of issuing credits for emission reduction, but now this system is being used also for sequestration. Next slide. And yes, so that's what I want to say. So the problem is that carbon sequestration standards are being developed in the likeness of standards for carbon offsets. And the real concern here is that counterfactuals continue to be used, even though for sequestration, which is inherently very different than emission reduction, there is no need for a counterfactual. Next slide. And this then brings up the question of how much longer can it continue to have questionable, I guess, quality. And I don't know. But if we look at attorneys, for example, I've seen a rise of these kind of articles warning their clients that they should be really careful when they purchase carbon offsets, because there are litigation actions coming online, and if all of these companies are going to be relying on carbon offsets to meet their net zero goals and make claims and say things to consumers, there are real consequences to using products that are not what they say they are. Next slide. And then the second part is that there's a lot more scrutiny happening from various different efforts to try and assess and rate credits and regulate their use, their claims, their trades. And so there's really a lot of trying to make things better. But from my high throne of a academic, it's easy for me to say, but and look at the whole system as a whole. But what we see is that that's all well and good, but it's likely not going to be enough because they are regulating a system that is already built on weak foundations. And without changing the foundations, we're just going to be perpetuating the same issue over and over again. Next slide. So there needs to be some rethinking with certification. I don't see other ways because this kind of approach to carbon accounting may have worked when the carbon market was small, when few people were using them to make claims. But here we're talking about a sequestration industry that's going to be billions of tons. It's going to affect most of the planet. The sheer scale of this industry will make it that the current system will not be adequate. At least that's where we think the writing is on the wall. Next slide. So I would like to implant some questions in your mind about where certification needs to do some rethinking. And it falls along at least 5 questions. There are more, and these other questions are related to governance, and they're related to trade and claim. But here I want to focus very specifically on the carbon accounting. And some of these questions may be, where can we neutralize, what can neutralize an emission? So that's the idea that we can use a certificate or we can use a credit to say that we have balanced out an emission. And to make that claim, we need to know some very specific criteria about the sequestration. One of them being, is this going to be permanent sequestration? The second being, has it been measured? So rethinking what can neutralize an emission is going to be critical. The second part is, once we have defined how we neutralize an emission, where do we apply the neutralization to have maximum efficiency? And right now we are, in this kind of system where we are applying responsibility in the middle of a supply chain. So we are expecting companies to do the offsetting and balancing, but that may not be a logical or workable approach when we start to switch to carbon sequestration. And the reason being that currently carbon offsets, they sell for $2, $10 maybe. But when we actually look at the more novel sequestration, we're talking about thousands of dollars. And even with innovation and bringing down the cost, we may be thinking, at very optimistically, we could get it down to $50. So the price that is being associated to neutralization in the middle of the supply chain is going to become untenable. And an alternative approach might be if we push that responsibility all the way at the source of carbon extraction. So that's kind of a set of questions that need to be asked. The second one is, what are the practices that are acceptable in certification? I showed you that one of the major lessons that I think we should be learning from all of the news story is that we need to move away from counterfactuals. But right now, counterfactuals are seen as an acceptable practice. And I think there needs to be some questioning as a community of certification of what is actually acceptable. And then very much tied to this is what are the tools to actually get us the evidence that we need. And the current tool that we are using is life cycle analysis. We are taking this whole system approach to estimating the net sequestration. And for many reasons, that makes a lot of sense. But if we actually want to be collecting evidence for sequestration to base certification, I would argue we need to be rethinking that tool as the right tool. And then the last part is, what does permanent sequestration mean? And this has been a debate for decades already. At some point in time, we decided that permanent sequestration meant 100 years. There are valid reasons why it might be decided one way or another, but if we want to take a scientifically valid reason, then 100 years cannot be considered permanent in the carbon cycle. If we want an economic reason, maybe 100 years is permanent. So reopening that debate and really walking through the consequences of the definition that we use, I think, is going to be an area that needs to be addressed. Next slide. And so now I just want to part you with some ideas of what is needed for more robust certification. And from our assessment of the space and the various research that we've been doing, at least at ASU and our partners, to us, it's all about having uniform technology agnostic rules. And the reason to have that is we would then create that oversight across all of the different standards. So at the very minimum, they meet certain criteria, so we can at least guarantee the same product. It needs to be technology agnostic because, as I tried to show you, we need this whole portfolio of technologies. We don't know a priori which technology is going to be economically viable at scale, with minimum impact, with verifiability, with permanence and safety. And so we want to have all of the possible tools available so that we can deploy at the capacity that we need. And so having these rules in a way that is technology agnostic and uniform allows for that broad portfolio. And by making sure the rules are agnostic means that we can create a level economic playing field so that we are not preferentially selecting one technology over another. We're letting the technologies compete on real measurable metrics. The second part is that we think we should really be moving towards evidence-based protocols. The trust that we are putting on sequestration requires that we have evidence and proof. And the protocols we are currently, the approach to protocol development we are currently using is not giving us that evidence. And we can talk about this if anyone's interested, but there are ways to target and guide the development of protocols to gather that evidence. And then the last part, which is really about making sure that sequestration is permanent, is a huge topic, but how do we make sure that we can have permanent sequestration while allowing all of those different types of sequestration reservoirs when not all of them will be permanent? And so to us, this means moving towards a remediation system so that any carbon loss from storage can be remediated and therefore keep the collective sequestration effort in its integrity. Next slide. And just so some key takeaways from this is that there is and there will be this growing demand for carbon sequestration. The writing is in all of the pledges that we have made. We cannot reach net zero without sequestration. This will be a massive industry. And certification is going to be critical to foster the trust that we need to make claims and to be clear about what we are actually accomplishing. And that means certification really needs to be robust and it needs to be believable. And then that means that considering where we are now with the status of certification, certain aspects will just have to be rethought. And maybe that's a, I don't know, extremist position. I don't know what to call this, but in our view, without rethinking some core elements, we are just putting a band-aid over a wound that's just growing. And I'm going to stop there. I'm more than happy to take questions, and thank you for your time.
Thank you so much, Stephanie. Wonderful seminar. So we're going to open it up for questions. If you have questions, please stay around. We will be back in about 3 weeks with our next seminar. If you have questions, please feel free to unmute yourself or type your question in the chat. Sanna, you've raised your hand. Go ahead.
Yes. Hey, I'm wondering if your research has helped you kind of understand in what sectors the certification is furthest along or most difficult to do, or because I'm looking at in some, like in industry, emissions are relatively easy to pinpoint to a source and measure, but from landscapes, for example, it's tremendously difficult. So do you have any insights on that?
Yeah, that's a good question. So just from a historical perspective, we've been the certification space has been working a lot on geological storage and forest sequestration the longest. And so just because of that historical focus, there has been more research on those two types of sequestration. It doesn't mean we've come to a point where we are, collecting evidence-based protocols or developing evidence-based protocols, but at least we have filled a lot of the gaps. We are least advanced in reservoirs that are in the ocean. I think that's going to be the trickiest one, just because it is so nascent, just in general, that we really don't have the answers to a lot of the questions that we need to be answering. And then I will say that if we look at protocols that are available right now, I think in general, some of the geological storage ones I think are almost there. And by almost there, I mean, like, if we think that evidence-based protocol is the goal, then I think they're almost there. There are several very technical points that I could get into that could improve, but it's definitely the furthest along.
Thank you. Stephanie, there's also a question in the chat. Is there a certification organization that you think is on the right track?
That's an interesting question. It depends on which variable we look at them. If we look at them on the whole, it's hard to say, because the accounting approaches that are being used in voluntary and in compliance-based markets, they use similar accounting approaches. So on that kind of criteria, no one's doing very well. If we're ranking things, which is not a very scientific thing to do, I guess. But in the overall, there are certain standards are more robust than others within that approach to accounting. I try to not pick favorites, so I don't have more specific answer to that.
Great, thank you. Other questions? You're welcome to unmute yourself.
This is Anna again. I can ask one more.
Great, thank you.
Yeah, because I'm very I'm curious about this what do you find the biggest kind of a gap? Is it the verification of how you calculate, or is it the verification how you measure or how you detect? So what comes as the biggest uncertainty, in your opinion?
Yeah. So I think the biggest issue with the current system is that we are defining the baseline using a counterfactual. And so we are, inventing this world, and yes, we're using data to invent that world, but it's still a world that we will never be in. And so we cannot verify that world. We can say it's plausible based on other observations, but we can't see it because it will never happen. And so shifting from a counterfactual baseline to actually measuring what's in the reservoir, I think, would be the most significant improvement that we can do. And that's a very different way of looking at it, because what the current approach is trying to do is measure the absence of carbon, right? The protocols are so focused on emission reduction that they are not as much thinking about proving that carbon is somewhere. And so having the sensors to start measuring what's in a carbon reservoir, where are the boundaries of that reservoir, how much are we adding to that reservoir, and can we say any of this with any certainty, is, in our opinion, really the critical shift that needs to happen. And by guiding the process in this way, by saying, hey, where's the carbon going? Do I have a method to measure how much I'm putting in there? Do I have a method to say how much is in there? Then we can start to have something called positive carbon accounting methods. And by positive, I mean developed in a scientific process kind of way, so that we can have this falsifiable hypothesis that can lead us to conclude that yes, the carbon is where it is, where we say it is, or sorry, no, we have lost carbon and now we need to do something about it. So I think that's the most critical shift in what we're measuring that needs to happen.
Thank you. Stephanie, we have one more question for you in the chat. What is the approximate price range per ton sequestered? And do the prices vary depending on duration?
Yeah. So the prices that I was able to obtain come with caveats. So the prices that I know of are from this database called CDR FYI, and they only look at certain types of carbon dioxide removal. So not very broadly thinking about, CCS prices, but just CDR prices, and very specifically some certain types of CDR within the CDR category. And what they report is anywhere between $40 and $1,500 for a ton sequestered, depending on the type of technology that is being used. And I think based on the quantity that was sold, it was for the year that they reported, it ended up being something like $200 per ton on average. But like I said, there's tremendous variation depending on the technology.
Thanks, Stephanie.
And actually, the second part of that question is, surprisingly, no, the prices are not varying by duration, because duration is not really included within the cost structure. And maybe there's someone on the call who could say that's not true, but based on certain analysis and publications that I have seen, the costs are not really considering, you know, the idea that there is that need to monitor in perpetuity, and there is that need to remediate all of the lost carbon from storage. It is included in some ways by saying we will have this fixed liability for, I don't know, 20, 50 years or 100, whatever that timing is. But that all depends on how we define permanence. And if we're thinking about permanence in a climate relevant way rather than an economic way, then the economics and the prices completely change. So, and that's, you know, that's not even thinking about the cost of the risk. So the prices are not really reflecting right now, at least from what I can see, the duration of the sequestration. But happy to be contradicted on that, because, you know, I'm not in industry, so I don't have that insight as much as someone who is would be.
Thank you, Stephanie. We will be back in 3 weeks with our next seminar. And for all of you who tuned in today, thank you so much for participating and listening and participating in this discussion. We really appreciate it. Thank you.